Okay, we're back in. And we've still got just the three of you here and me. So let's go over how things are going to wind down this term. Jordan, have you been able to determine if Andy's can hear me yet? He cannot. Okay. I can't hear Jordan either. Oh, he is. Okay. But I thought maybe he would be. I wonder if Jordan can hear. I assume Jordan can hear me. Is that right?
Yes, sir.
Okay, good. Okay. Let me see. I keep getting something popping up here and I can't tell why. Yeah, Andy's microphone doesn't even show up now. Um, and now it does, but it has a bar through it. His video isn't showing up, and now he's off again. So he must be dealing with the issues. But let him know I am recording, so when he does come back in, he'll can pick up anything he missed on the YouTube video sometime later today. It'll probably be in the afternoon, evening type time frame. Okay. Any questions, issues, concerns before I get back to where I was? Anything?
No, sir. But he said he's starting his computer.
Okay. Um, I will say this. There have been some rather bizarre computer issues this morning. Now, they may not have anything to do with Andy. They may not be related to each other, but there are some strange things going on. This morning, fairly early, I was working on Blackboard. Okay. My wife came home from physical therapy. I went down to tell her that the plumbers were going to be here sometime this morning. I had given them her cell phone because they said it may be around 11. I knew I'd be in this class then, so I didn't want to give them mine. When I came back up, I wasn't gone but a few minutes. Came back up, Blackboard was checked out. It was no longer operating. So I went out, came back in, could not log into Blackboard. And so I called Dr. James, couldn't get her, left her a message, and then I called Miss Glass, and she's always on top of everything. And she said it must be down because she had just gotten 3 phone calls in a row from instructors who were not able to do Blackboard. And she had already called Jim, the main IT guy, and he was working on it to see if he could figure out what was going on. So a few minutes ago, just before class, she called back and said it looks like it's back up again. Um, Email. I was on email then after I couldn't do Blackboard anymore. I was trying to do email and suddenly I got a screen came up that said privacy notice, there could be someone attacking the system. So I went, what? So I called Miss Glass back again. It hadn't been 5 minutes since I called her before and talked with her and told her that error screen. And then because I had opened the attachment, I went on and finished the attachment, and that got me right up until class time. So I don't know if email is working now. Um, I assume that it was just something bizarre, but I don't know. So there are some weird things going on cyber wise today, it sounds like. Okay, but just to get that out of the way, um, let me what I was starting to say before, let's go over how we're going to wrap up the term. Okay? We're in 8.7 today. This is the last section in chapter 8 we'll do. Hopefully we'll get it finished today. I think it's a relatively short and easy chapter to do. Section to do. And I've opened 9 so that if we do get to 9, we'll get there. But now I'm doing all this talking. That's eating up time. Okay. And I don't think we'll get past 9.1 and 9.2 before the end of the week. So what I'll do on Wednesday, day after tomorrow, after class, I'll determine how far we went, and then I'll modify what I was going to give as the chapter 8 test and just add maybe a question or two from chapter 9. So it'll be a little bit longer, but not, I'd say, any more difficult, um, because those are pretty easy questions, I hope. They usually, students do pretty well on them. So I'll probably do one question out of section 9.1, and if we get to 9.2, one question out of 9.2. So you'll have either 11 or 12 questions on the last test. I'll give it to you. We'll have class on Wednesday. Goodness, my nose is running. We'll have class on Wednesday, and then I have another Cal 3 class after that, then a differential equation class after that, and then after that I will get the adjustments made to the last test and then post that. I don't know if Blackboard is so bizarre. Sometimes I can post the test under where you would think it should be, and other times I can't. There is a folder there called Final Exam, and if I can post it under Final Exam, that's where I'll do it. It's after the weekly activities, those kind of things. Okay, here's Andy coming back in. Let me see if we can get him this time. Okay. Okay, Andy's name has popped up. I don't see any devices, as in a microphone, yet. So I'm assuming, there's a microphone with a mute across it, but I can't tell if he can hear me. So if one of you,
I can hear you.
you can, fantastic.
I think it was the update that I had to do to the Zoom.
You think it was what?
I did an update on Zoom.
Oh, I see. Okay. All right. Glad you're here. Okay, I just started going over some of the things. I was just saying to the others that there had been some really weird cyber events happening this morning. First, my Blackboard went out sometime between 9 and 9:30. It went out, and everybody else's went out too. So if you were on Blackboard then, you probably realize that. If you weren't and were trying to get on, that's why you couldn't get on. But supposedly it's fixed now. They got it fixed right before this class started, so I didn't have a chance to get back on it. When after Blackboard went out, I was working on emails, and the first email was a fairly lengthy 2 attachments, and I was working through those, or the first one of those, when I got a message that cybersecurity or something like this, someone may be attacking my system, blah blah blah. So I called the IT person back. It hadn't been 5 minutes since I'd hung up with her on Blackboard, and I was telling her what was going on with email, and she hadn't heard that one yet. She knew the Blackboard was out, but she hadn't heard that on the thing. So she was, I was giving them plenty of business this morning. So anyway, I was able to finish reading the attachments because they were already open, and then I closed out email. I don't know if there's any problem with that yet, but supposedly Blackboard's open. So don't be surprised if there's weird cyber issues today. It sounds like a bad day for it. Now, I was also talking about what we're going to do for the end of the term. We're in 8.7 now, and hopefully we'll finish it today or come awfully close to that, and then move into 9.1. If we get to 9.1, and on Wednesday, if we get to 9.2, then what I'll do, what I was going to give you is the Chapter 8 test. I'm just going to add one question from 9.1 if we get that done, and maybe one question from 9.2 if we get that done. They'll be pretty straightforward, hopefully, fundamental questions on what those 2 sections are talking about. So hopefully that won't be a great increase in difficulty. It'll just be 2 more problems on the test. So after class on Wednesday, I have another Cal 3 class coming up, and then a differential equations class. So sometime after 4 o'clock, I will be trying to get that Chapter 8 test adjusted for those last two questions, get those on, then I'll be sending them to them. Now, what I was saying when you came back on, I don't know where I'll post them. There's on Blackboard, you know, week 16 has supposedly a place where I can do an assessment. So it may be under week 16, and if you see a final exam listed there, that's where it'll be. I'm first going to try under, there is a tab called, it's either called midterms and finals or just final, I don't remember which. I'm going to try to put it there first, but sometimes they allow me to put things there. Blackboard, I find, is an awkward program. I don't know if you find it that way or not, but the system, you would figure it, has decided. We had several other course management systems that applied to the system of Alabama to have the contract for the whole system, and Blackboard was one of the 4 companies that were in the finalists. And Blackboard, they had the slickest presentation, I think, and that's what convinced them to go with Blackboard. What they never said in Blackboard, which all the others said, the others were built for online situations. They were built for remote devices. They were built for phones and all the things. Blackboard was, of course, has been around for decades. They were built for desktops, maybe even some laptops, but they've been trying to kludge in the mobile devices. They haven't done a good job, I don't think. I don't know if you think they have or not, but the system went with Blackboard. So here we are with this kludgy old system. My wife always complains about those businesses like Walmart, Sam's, Home Depot, the others who were box stores, and then they tried to get into the internet, and their internet systems are just really clumsy. Whereas Amazon's and places like that, who started out being an internet business, those run so smoothly. Same thing with Blackboard. It's just a kludgy old system. So anyway, enough of all this talk. Let's get down to calculus. So the final exam, I'll try to put out there under the final exam. If I can't put it there, I'll try to put it under week 16 assessment, and I'll rename that final exam. If I can't put it either of those places, I will put it under Blackboard Messages. Okay, I may put it under Blackboard Messages nevertheless, just as a backup, but I'll try the other 2 places first. But that will be sometime after, between 4 and 10 o'clock Wednesday evening. I'll try to get that done as early as I can on Wednesday, but I never know what's going to happen between now and then. So anyway, any questions before we get started today on example 1 in chapter 8? Chapter 8 is integration techniques and improper integrals. We're just focusing on integration techniques. We're in 8.7 now, integration by tables and other integration techniques, and we're on page 567, example 1. Any questions? All right. Sorry I've spent that much time just getting introduced to it. All right, so here's our problem. Now we could try to figure out a way to do that by some other means. Perhaps an integration by parts, though it doesn't look like that's going to be likely. But what the section is integration by tables. So if we go to the back of the book, and I did have this mark back here, and yes it is, that's my mark, okay. This is, and remember in the back of the book, this is Appendix B. I wish I could give you a page number that made sense to help you find it, but the page number is A3, which doesn't really tell you much at all. The last page in the text is 1128, 1128. The next page after that is your appendix page. Appendix A is A2, I guess that introductory page is A1, the next is A2, and then the integration table starts on A3. So go to the back of the book, but not the very back. You have an index back there, you have your answers to the odd number problems back there, you have lots of junk back there, stuff back there. But just after the last thing in chapter 15 is integration by tables. Now, on the integration by tables, we talked about this last Wednesday, but I'm doing a little bit of review here. They break it down by types of, I'm sorry, I just hit one of the stupid buttons on my Wacom pad. Okay. And the first group is called forms involving u to the n. Well, we know how to do those, so it's not there. Forms involving a plus bu. Well, there is an a plus bu sort of in here, but there's plenty others that. It's not that one. Forms involving a plus bu plus cu squared. Okay? No, don't have any squares in it. Now, forms involving a plus b, the square root of a plus bu. That looks promising, especially when you go down to number 18, which is the last thing in the table on page A3. Okay, that looks like what we've got here. Okay, and I'm going to write down what 18 is here. Okay, 18, I'll write it down as 18. This is in the table, 18. The integral of 1 over u to the n times the square root of a plus bu. Now, I'm not saying this is it. I'm just giving you this as a close example of this, du. Okay? Now, of course, here they're using u's. We're using x's as our variable. Okay? So, how do these pair up? Well, it looks like let u equal x. Okay? N would equal 1 because this is x to the first power. Okay? Your a here is equal to -1, and your b is equal to 1 because the coefficient for x is 1. That looks like a pretty good match. Okay? Now, let's see what they say the answer is. The answer is -1 over a, which is a -1, times n minus 1. Well, n is 1, and n minus 1, okay, how did I miss 17? I'm sorry. Let me go back. I was going to say, this doesn't work at all, and that's because I completely overlooked 17. Okay, let's see what 17 says. It's the integral of 1 over u, not to the nth, times the square root of a plus. That's it. Okay? Now, it does have two parts to it, though. Okay? Now, let's do, we don't have the n in here at all. Okay? That was my bad. Okay? But what is the answer to this one? Okay. Well, this one has two answers. It has one answer for a greater than 0 and another for a less than 0. We have an a of -1. So that's less than 0. So we're going with this answer, 2 excuse me, over the square root of -a, which would be the square root of 1. So that's just 1, okay? Times the arctangent of the square root of, and it's a plus bu. I'll write it down this way. a plus bu, there I say a plus bu and write it backwards. Rather than doing that, because in interest of time, let's go on and plug in what it is. Okay. Let me get my pen back. Okay. Now, notice here, the a plus bu, square root of a plus bu is the same as this. That's the same as this. So rather than writing that, I'm going to write the square root of x minus 1. Okay, that's what it is, over a negative a. Well, a is a negative 1. That's just that. Okay, and then you have plus c. That's it. There's your answer. Okay, so what do we have? Our answer is 2 times, I prefer inverse tangent. It doesn't matter which you use, the square root of x minus 1 plus c. Pretty simple solution. Okay, it was our inverse tangent rule. Okay, any questions on that? All right, what I'm going to do, where am I going there? Well, let me just make sure, since I am there, that nobody else is trying to come in, that we don't have Ashton somewhere. All right, so I'm going to erase the, if I can get it to erase now. Here we go. What I've scribbled, if you'll remember what answer we got, and let's see what they do. Because the expression inside the radical is linear, okay, you should consider forms involving square root of a plus bu. Even though this is written in the reversed order, it's okay. You can deal with that. And number 17, formula 17, for a less than 0, this is what you had. And that was 2, yeah, that was the whole thing, whole caboodle there. And let's figure out what represents what. Obviously, the x's are u's. The a is a minus 1. That's why we used a less than 1 over here. And the b is equal to 1. Okay? So 2 over the square root of minus a minus 1, that would be 1. That would just be a 2 times the inverse tangent of, and this expression here is what's under the radical here, so we just put what's under the radical there. X minus 1 over a minus a negative 1, which is 1, so that we can leave that off, plus c. So there's our answer right there. Let a be negative 1, b is 1. See, this a is your negative 1 from there, b is the positive 1 from there, and u is equal to x. I don't know why they didn't start with u is equal to x. Anyway, so that answer then, du is dx, and you can write that integral here, very one we had, is 2 times the inverse tangent of square root of x minus 1 plus c. And that's exactly what we got. Now, let me put this back in place. Too many moving parts here today. Flipping from front of the book or middle of the book or to the back of the book, back and forth. They're skipping example 2. So rather than going to reduction formulas, let's go to example 2, which I did set up. Hopefully it's still set up, the whiteboard. Yeah, it's there ready for us. And here's example 2. Let me get my book in my lap because it's on the opposite side of the page and it's hard to read. Okay, here we go. We got the integral of x times the square root of x to the 4th minus 9 times the dx. Now, looking at that, it sort of smacks. Of course, if this x out front here had a cubed on it, that would be a simple substitution problem and we could go to town. We wouldn't need a table. Okay? It doesn't. The next thing I would consider would be a trig substitution, and this would be a secant, I think. Let x equal secant theta. And then sort of go from there. Now that would be a bit on the messy side because, well, you have it's a square of a square, you know. Well, then it may not work anyway. So let's go to the tables. That's a messy enough problem. Let's go to the table. Okay. Now, this is, in some senses, looks a little simpler because you don't have a denominator, but you have what's under your radical is a u to the n. They use u's in the table. Okay, so this is not a linear form under the radical, so where we left off last time wouldn't work. The first three headings don't work either. Flip the page and get to forms involving a squared plus or minus u squared. Well, if a squared was x, if a was x squared, and I'm sorry, if a was 3 and u was x squared, that might work. But when you look at the ones they list under that one, that doesn't look very promising because none of those are under radicals and they're all in denominators. So let's go down to forms involving the square root of u squared plus or minus a squared. Again, the u would be x squared and the a would be 3. Okay, well, let's see if any of these seem to match. Okay, the first one would be okay except it doesn't have the x in front. The second one would be okay except it has an x squared in front. I mean a u squared in front, not a u. Okay, the third one has a u down in the denominator. That doesn't seem, this is number 28. I'm looking at 26, 27, 28 on your page A4, if that's at all helpful. Okay, so that doesn't look good. 29 is more similar because it's a minus sign, but again, your u is in the denominator, not in the numerator. Then we have a u squared in the denominator. That looks further out. Now we have the whole radical in the denominator. That doesn't seem promising. And all the rest of them are in the denominators. We may come back to that. Okay, let's hold our horses on that one. Let's look at forms involving a squared minus u squared. Okay, now this is not exactly what we've got, but let's see if those can be adjusted. If our a was, that's going to be tough. I don't think this will work either. Let's just look at those. And then they have sines, tangents, inverse things, e to the u, log u's, hyperbolics, and inverse hyperbolics. None of those seems to fit. They sure don't fit very well. So the most promising one I think we saw was goodness gracious. I would have to go with, yeah, no. Boy, I don't like any of those. Okay, let's see which one they wound up with. They say formula 26, that's the one I was looking at, but it doesn't seem to fit here all that well. So let's see what we get. Okay, they say go with form 26. So let's go over here. If I can get my pen to agree, let's do number 26. That is the integral of u squared plus or minus a squared. I'm just going to go with the minus a squared. Okay? And it's the square root of. We certainly need that in there. Okay, du. All right. And what is its answer? That's what the table gives you as an answer. 1/2 open parentheses u times the square root of, and again I'm going with the minus only, u squared minus a squared. This pen is just really doing poorly today. Okay. And we're going with the minus a squared times the log, natural log, and I didn't leave enough room here, of absolute value u plus the square root of u squared minus a squared. Okay. Close absolute value, close parentheses, plus c. All right. Let's see how this lines up. Okay. Let, I don't know where I want to write this. Maybe I'll write it here. Let u equal x to the 4, x squared. Okay, because you're going to square that and you'll get that. I think this will work okay. A is equal to 3, because 3 squared is 9, and it's a minus 9. Okay, what would be your du then? Then du is equal to 2x dx. Hey, that'll work because we got an x dx here, so we'll want to do let's think about which way we're doing it. Let's leave it like that for now. We don't divide by 2, I don't believe. Okay, now it looks like we got what we're looking for, except that we need the 2 out front, because the du from here is equal to 2 dx, so we'll need a 2 in front of that integral. Okay, I hope I'm doing this in the right order. X squared minus 9 dx, and that should equal to 1/2. Now, what is your u? X squared. What I'm doing is plugging in here, times that radical of x to the 4th minus 9, that's what this is, minus a squared, that's your 9, a was 3, a squared was 9, times the natural log of absolute value, u was x squared, plus the square root of x to the 4th minus 9, absolute value, close, plus c. Alright, now 2 times that is equal to this, so let's now divide both sides by 2. So that makes this a 4 here. Ooh, that's ugly. Okay, so let me get my eraser in place and make that a 4. 1/4. Okay, That's what my guess is of your answer here. Let's see what they got. Okay. Example 2. 1/4, open parentheses, x squared times the square root of x fourth minus 9 times the log of absolute value x squared plus x fourth, the square root of x squared fourth minus 9, close absolute value, close parentheses, plus c. Got it. Any questions on that? Okay. Had to do some monkeying around with the x came from the fact that the u was going to be x squared, so the du gave you a 2x. So that's where the x came from. Okay, so this didn't fit anything in the table super well. We picked something that it came close to. Okay, and the fact that the x squared produced a x when you took the derivative of u, that did it for us. That put the 2 on the outside here to give you this thing here, but then we only wanted one of those, so we here did this so the 2's we cancel out, but that's where we went from a 1/2 here to a 1/4 here by dividing by 2. Any questions on that? All right. If there are no questions, I'm going to clear the screen. Any questions? Okay, let me just check and make sure that Ashton isn't waiting. Doesn't appear to be. Okay, so let's move on to example 3. Evaluate this one. I think I'll get this back in my lap again. It's because it's hard to read from over there. And this will be the integral. Now this is a definite integral. 0 to 2 of x over 1 plus e to the minus x. No, minus x squared. Okay? dx. Okay. Now, actually, folks, this doesn't seem to be quite as difficult as maybe it looks, because what we've got down here, if you let the innermost part, wherever it is, there it is, innermost part, the most complicated part of this would be your minus x squared. Derivative of that would be a minus x dx. So that looks, or minus 2x dx up here, that looks like it might be promising to do a substitution. And that would give you a du over 1 plus e to the u. Okay? Minus du. You know, you have minus signs and 2's in there and stuff. You'll have to deal with those. But I don't know. You don't have an e to the u to be taken care of in the numerator then. Okay, so that may turn out being a little more difficult than we thought. So let's go to our table to see what we get there. Okay, now obviously all the ones we've looked at before were polynomials and radicals of polynomials. So on the first page, A3, nothing helps us there. A4, nothing helps us there. A5, nothing helps us there, because now we're getting into trig functions. We don't have a trig function here. The top part of A6 also is trig function, but then you get a form involving e to the u. Now 81 is patently obvious. We don't even need to go to a table for that one. I don't think we would for 82 either. Or 83 is integration by parts. That's a fairly simple. But now the 84, that's describing something like what we've got here. So I think 84 is the one that we look to. Okay, so let's write down what 84 says. Okay, this is from the table. The integral of 1 over 1 plus e to the u. The pen is not writing well today at all. Du is equal to, and this is what they tell us the answer is, u minus the log, figured that had to be in there somewhere, 1 plus e to the u. Plus c. Okay, let's see if we can translate that. Now I'm going to try to clean this up a little bit. Well, maybe I won't. There it goes. That was pretty ugly there. The pen didn't want to write a U there. I got the U to write now. So in this problem, the let U equal minus x squared, because that's what we've got here. 1 plus e to the u. Here we have 1 plus e to the minus x squared. So e would be that. Then du would equal minus 2x dx. Okay? Now, we don't have a minus 2x dx. We have a minus, we just have an x up there. So, I don't know. I guess you could do it the way we used to. Let's try that. And let's divide both sides by a minus 2. Okay. So what do we have now? We have the x dx is minus du over 2, so this will be a minus 1/2 the integral from 0 to 2. I think I like doing it my other way better, but we'll see if this works. Okay. Now, what do we have now? We have our x dx here, and this should equal this stuff over here. What is our u? A minus x squared. Well, let's see. I don't think I need the integral sign anymore, because we're going on and doing our substitution. So let me get rid of that integral sign. Okay. We need to remember the limits. That was the main reason I was doing it, but we don't need it anymore. Okay. Minus 1/2 is out front, and then the integral from 0 to 2, we just got to put that at the end. Just don't forget to do that. And that would be u, which is a minus x squared, minus the log of 1 plus e to the u, and that would be 1 plus e to the minus x squared. Okay, plus c. Whoa, look, forget the plus c. Evaluated, that's what I was trying to remember, from 0 to 2. So let's do that part. Minus 1/2. Now, well, let's go on and do it. That would be a minus 4. 2 squared is 4. Minus the log of 1 plus e to the minus 4. Okay. Minus, which will be minus a minus, which is plus. But when you put a 0 in for x squared, you get 0. So that's not going to add anything. But this one will also be a minus, will be a plus the log of 1. Because you put a 0 in for x squared, it's a 0. E to the 0 is 1. So that's 1 plus 1 is 2. Didn't know you, 1 plus 1. Didn't know you'd be doing such high-level math today, did you? Okay, so this will be a minus 1/2 times a minus 4 minus the log of 1 plus e to the minus 4. This is really writing poorly today. Plus log 2. Okay, now if you divide by the minus 1/2, this will make a 2 there, plus 1/2 times the log of 1 plus e to the minus 4, which you can do some things with, and we will if we need to, plus, or no, that now becomes a minus. This is one thing hazardous about all these minus signs, is that remembering that would be a minus 1/2 log 2. Now, what you can do with a exponent, with a coefficient in front of the log, is bring that up and make it the exponent of the argument of the log. Okay, so that's one thing we could do. We could do it there and do it here. Don't know if that's going to help us any, but you could do that. Another thing you could do is make this 1 plus 1 over e to the 4th, which would be a e to the 4th plus 1 over e to the 4th. I don't know if that's beneficial or not, but when you did that, then this 1/2 that you raised as the exponent here, that denominator, which was a e to the 4th, would then become an e squared. And that may be how they do it. So let's see how they write their answer. This answer is, I'm convinced, is correct, but it may not be the one they write down. Let's see which one they do. Okay, they left the 1/2 out front. Okay, what they did, they changed the signs of everything, which I was going to do, plus, 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 and made that one the minus. Okay, all right, that was a fairly easy fix. Okay, so they wound up with 1/2 open bracket 4 plus the log of 1 plus e to the minus 4, they left it like that, minus log 2. And that's how they left theirs, and then they pulled out their handy dandy calculators to see if they could evaluate that, since that is a number. And let me see if I can get my phone to do that operation. I've been having difficulties with my phone, and my wife has cleared off a lot of stuff, so finding things are a little harder now. You know what I'm going to do? Rather than all the parentheses and stuff, I'm going to use my form at the bottom and see if we get the same answer. Okay, so that's going to be a 2 plus 0.5 times, I'm going to have to turn my calculator sideways to do a log, I've got to do the argument first here. That's going to be a little bit of a problem. So I'm going to open my parentheses and do a 1 plus, and then I got to do another parentheses, I think, because this phone is a little squirrely. 4 plus minus, change the sign to a -4, then do an E function. Okay, all right, and then close that parentheses, and do a log function. Oh no, it gave me something totally wrong. Okay, well, maybe it was right. Let me continue. Minus 0.5 times the log of 2 times 2 log equal. Yeah, did something really squirrely there in the middle. So I'm not going to argue strongly for using phones as calculators because they do give you some problems. Let me try it again. 2 plus 0.5 times, okay, open parentheses, 1 plus 4, change sign, this time I'm skipping a parentheses, E, close parentheses. That time it worked better, okay? Log of that minus 0.5 times 2 log equal. Nope, still gives me a wrong answer. Yuck. Maybe I hit a plus there rather than a minus. This is not worth wasting time on, but I'm going to try it one more time. 2 plus 0.5 times, open parentheses, 1 plus 4, negate the 4, raise it to the E, close the parentheses. That worked so far. Then did a log, natural log. That worked so far. Then do a minus, okay, 0.5 times 2 log equal. No. I don't know if something's wrong with my syntax on my phone or if I'm doing something wrong. Let me try their answer, which is even worse. Okay, let's clear that. Okay, 0.5 times, open parentheses, 4 plus, open another parentheses, 1 plus 4, negate that, do an exponential, close that parentheses, take the log of that, then subtract. No, there's something really bizarre here. Yeah, no, that's all right. Subtract log 2, close the outer parentheses, and hit equal. And I get the same answer I did before. I have a feeling their answer in the book is wrong. I get 2.31. Did any of you do, oh. I think I did it right. Did any of you try it on your calculator? Anybody? Have we still got anyone listening? Okay, it's not worth wasting any more time on. I got 2.31 about 3 different ways, so I'm going to say either my calculator is consistently doing something wrong, or I'm consistently doing something wrong, or else that's the correct answer and not 1.66. So, because looking, well, wait, let me do something else. Let's divide that by 2. That doesn't work either. Okay, I was thinking that came awfully close to giving it. When I look at their graph here, that's something less than 4, half of 4, which would be my 2.31 doesn't look like it's right. Okay, so
1.66.
you did. Okay, so it is right in the book then. Thank you for doing that. Obviously, phones are not the best calculators. Okay, there's some sort of syntax error that if I was doing it on a calculator it would be correct. On the phone it doesn't seem to be correct. So anyway, let's put that aside. Sorry I took so much class time doing something wrong. Pain in the neck. Okay, sorry about that. But that was example 3, and they did get the correct answer. So anyway, let's move on to reduction formulas. That's back at the PowerPoint. So let's go back to the PowerPoint 8.7. Resume the slideshow here, and we'll go to reduction formulas. Several of the integrals in the integration tables wind up with the form of something like this. The integral of whatever that function is you're trying to do, dx, gives you some function plus some other integral, h of x. Okay? Now this isn't how they look in the back of the book, but you'll get the connection later. Such integration formulas are called reduction formulas because they reduce the given integral into the sum of a function plus a simpler integral. Now you can't tell looking at this is any simpler than that. Believe me, it's got to be, otherwise these wouldn't work. So in other words, if this was to a certain power, this would be to a lesser power. Okay? Something such as that. And then if you needed to do it again, this would give you another function you could do, and then the power is reduced again, and at some point you get down to something that you can actually integrate that last function. Sometimes you can do it in 1 step, 2 steps, 3 or 4 steps, as many as it takes. The key is this form here is simpler than that form. So you can keep doing it over and over again, and it keeps getting simpler. And here is one of those examples. Now this would be worked by integration by parts, okay? But we're going to use the table because that's what they want us to use. So let's go back to the table. And I thought this would go pretty quickly today. Okay. Now this does involve a trig function. So I'm in the, if you're in the table, page A5, and let's see if you can find something there on A5. Forms involving sine u or cosine u. We have a sine x here. Well, number 54 looks like it fits the bill. Okay, so let me get, if I can, there, find my cursor here. Here's number 54, and that is the integral of u to the n sine u du. This is a pretty simple substitution there. Let's let u equal x, then du is equal to dx. That was pretty straightforward. Okay. The only other thing we have is n is equal to 3. Okay. And I think the rest of it is doable. Okay. Well, what's the answer to this thing? It will be minus u to the n cosine u plus n times the integral of u to the n minus 1 cosine u du. Almost ran out of room there. I really did, but I just crammed it in there. Okay, well, what does that give us here? This would be a minus, the x is u is x, so that would just be x cubed, you use the same n, times the cosine of x plus n, which is 3, times the integral of u, which is x, to the n minus 1. Well, that would be squared. Okay, and then we have cosine x dx. Okay, that is a simpler form than this. Not a lot, but a little simpler. Okay, well, don't forget the first part. Minus x cubed cosine x plus 3. Don't forget that. Now we need to do this part. X squared cosine x dx. Well, if you go right across the page to 55, you'll see that the integral of u to the n cosine u du is equal to u to the n sine u minus n times the integral of u to the n minus 1 sine u du. Again, basically ran out of room. All right, now this is a different substitution. The u is still x. Okay, then the du is equal to dx. That's still good, but now the n is 2 because we're doing this one. N is equal to 2. The rest of it will work. So what does this give us? 3 times, oops, I started to put u. I did put u. I meant to put x. So this will be x squared, going from here, sine x minus 2 times the integral of x. Now n minus 1 would be just x sine x dx. All right. Whoa, whoa, whoa. Yeah. Let's write down what we know so far. Minus x cubed cosine x plus 3x squared sine x minus 6, because this 3 times that 2, times the integral, and I think I'm going to put this back in this again, x sine x dx. Now, again, an integration by part would have done the same thing, but we're using the table. If we look at this, now move up to 52, and 52 is exactly this one. And the integral of u sine u du is equal to sine u minus u cosine u plus c. Okay. And here is a simple thing, just x equal u. And du is equal to dx. So this just is a direct translation here. So what do we have? Minus x cubed, don't forget the first part, cosine x plus 3x squared sine x minus 6. Now we'll do this substitution, okay? That's just going to be a sine u. Minus 6 times sine x minus x cosine x plus c. Now I'm going to close this off and put my plus c out here. It's just a constant. All right, and I'm going to rearrange an order here too. Okay, I don't know why they did the sine u in front and u sine u later. Maybe because of the minus sign, I don't know, but let's go for it. Minus x cubed cosine x plus 3x squared sine x. Now here's where I'm going to reverse the order. Plus 6x cosine x minus 6. Ah, here comes Ashton. Good deal. Perfect attendance today, folks. Way to go. I've got to find my pen. I don't know what I've done with it now. There it is. So I can mark Ashton here. Ending November with a perfect attendance. That's the way to end it. And let's start December with a perfect attendance on Wednesday. Okay, Ashton, we're right at the end of finishing example 4 on page. I get my bookmark in place here. In chapter 8, integration techniques, going to stop right there. 8.7, integration by tables and other integration techniques, on page 568, top of the page under reduction formulas, example 4. We're almost at the end of it. I was just filling in the last little bit, and that was a minus, get out of there, minus 6 times the sine of x plus c. Okay, now let's see how the book did. Minus x cubed cosine x plus 3x squared sine x plus 6x cosine x minus 6 sine x plus c. Now I'm just going to point out a couple of things for you. Okay. Number 1, notice how the exponent, and if you remember this for integration by parts, there was that technique that we had by doing it by tables, and this reduced, and this one just flip-flopped back and forth between sine and cosine alternating signs, SIGN signs. So this started off with a minus x cubed. It goes to a plus 3x squared, which is the derivative of that, by the way. Then it goes to a plus 6x, which is the derivative of that, and then it went to a minus 6, which is, except for the minus sign, the derivative of that, and then you had your constant, okay? Whereas your sines and cosines, it started off being a positive sign, so it starts off down here as a negative cosine, then it goes back to being a positive sign. Now why? Because the derivative of cosine is minus sine, but this is a minus cosine, that gave you a plus sign. Derivative of a sine is a cosine, and that gave you a cosine. Derivative of a cosine is a minus sine. So that's where your sine SIGN sign changes came from. The changing derivatives of your trig function, that gave you the minus, plus, plus, minus. Your polynomial part with the signs in place there is x cubed, 3x squared, 6x, 6. The derivatives going downward of your polynomial part. Put them together and there's your answer. All right. Any questions on that? Let's see how they did it. I have a feeling it's awfully close to what we did because we came up with exactly the same answer. Consider the three formulas listed below. Now they start off, this to me is ridiculous. You can't look at that problem and say, oh, I'll need this one, then that one, then that one. Do the problem, okay? Do the problem and then see what you need to do. This is not the same as what we have there. Why they start out with 52? It's only because that's the last one they're going to use, okay? 54 is the one we started with. That should be where they started, and then they go to 55 because the cosine here, this one here, is more like this. So then you'll go to 55, and then when you finally get this down to, and again, you can't see this clearly the way they're doing it. I can't even find my cursor here. Where did it go? There it is. This started off a u cubed, stayed a u cubed here, became a u squared here, then this u squared became u to the first power here, still a u squared here, but u to the first power here, and then that's where you went up to use this one. So I prefer it listing these as you did. 54, 55, then 52. I think listing them like this means you can look in a crystal ball and know what you need. You can't do that. You have to give what the problem. I don't know if any of you ever played baseball. I never did. I wasn't any good at it, so I never went out for it. But I've heard so many times you go with the pitch. You don't swing like it's going to be a fastball and it's a curveball. You're going to strike, you know. You go with the pitch. Well, that's what you go with. You start with this because that's where you started, okay? And you got to a form here that was fine, but this form then was one that looked like this. So then you go with this one, 55. That gets you down to one that looks like this, so then you go back up to 52. You don't automatically look and say, well, I'll need this one, that one, and that one. You go with the pitch. Go with the ones that look like you need. Okay? So now they say using them in that order, but you don't even know which ones you need. Well, if you're real good at it, maybe you do. This one would be that one, just like we did. The minus u to the n cosine x plus n 3 times the integral of x to the n minus 1, which is x squared, cosine x dx. Okay, now we have a problem with this one. We got the first part done here, but we need to do this one. That's where we use 55. Okay, so this part stays the same. The plus 3 stays the same. Integrating this part gives you x squared sine x minus n 2 times the integral of x sine x dx. Okay, then this one will give you, let's see how they do it. Yeah, they did it a lot like we did. Minus x cubed cosine x plus 3x squared sine x all right, they skipped a huge step here. What they did was correct, but it skipped a really huge step by listing what this was. They didn't list what it was. It was back on the previous slide. They went on and plugged it in, and that gave them, this came out being a minus x cosine x. When you go back there, you'll see that. And that will be a minus times minus is plus 6 x cosine x, and then minus 6 sine x plus c. So the way they did it to me was very, very awkward. Maybe you thought the way I did it was awkward, but you know, you can see each step and where it came from. Now, that was example 4. They're skipping example 5. How are we doing on time? My watch is being recharged right now. 11:23. We have until 11:40. Got 17 minutes. So let's see if we can get example 5 done on the white pages. Whiteboard. Sorry. All right. All right, to clear it. Okay. Now, here's our issue here. Find this. If I can find my board here. There we go. The integral of the square root of 3 minus 5x. Have to write awfully slowly to get this to not screw up. Over 2x times dx. Now that's a rather bizarre looking form now. Let's get our, I'm not even going to suggest what actual techniques you could use. But what I am going to say, sorry about this, I've got to go make a quick head call. I thought I could wait. That's why I checked my watch. Don't think I can. I'm going to pause the recording. Do y'all have any questions before I go? I've just got to run down to the restroom. Hold on. Okay. All right. Here's the form we have. Now this is going back to one we were looking at before. This is one that is a radical linear form. And that would be bottom of page A3 is where I would start anyway. Okay? Now, it certainly doesn't look like any of these directly. It comes closest to me to looking like number 16. Okay, now what doesn't look like 16 to me is the n here would have to be a negative number because it's over 2n, not 2n in the numerator. Now again, that's my first guess, and since we have such limited time, I don't want to spend a lot of time on this if it's not the right guess. So let me go back and see which one they were going to do. They actually say 17, which I would not have considered. Let me make sure I'm looking at it right. Oh, they're doing it again. Okay, I didn't turn the page. I should have. Yeah. Looking at page A4, it's 19. That's the one we need. Okay, um, and that does fit the bill pretty nicely. They started with 17, which again, they're doing things backwards. Okay, so here's number 19. Sorry, I should have flipped the page to see. Okay, and that one says the integral of the square root of a plus bu over u du. Okay, and here's what the answer for that one is. I've got to sneeze. Sorry about this, folks. Sorry. I'm hoping it's just the change of weather and nothing else. Um, just to let y'all, I think y'all were in on what was going on the last couple of weeks with me and my health. I went in again this morning. I don't know if you noticed that, for blood work. I should have taken this off. I even forgot I had it on. Because I have a feeling I'm still anemic. Now, I don't think I'm critically anemic like I was a couple of weeks ago, but I'm still anemic, or I'm pretty sure I am. But they wanted to see how things had progressed. I may have to go in again this Friday for another blood transfusion, but hopefully not, but we'll see. Anyway, just to fill you in on that. Anyway, this thing here, number 19, gives us, if I can get my pen to stay still, 2 times the square root of a plus bu. Goodness gracious, this thing is such a pain in the neck. Plus bu. The pen is so awkward today. Plus a times the integral of 1 over u times the square root of a plus bu du. Now, you might note this was one like the one I was looking at earlier, not the same one, but similar to it. This is going to take us to another form, which happens to be what they were referring to, 17. We'll come back and deal with that in a minute. Let's get this one situated. In this problem, how this relates to that. Okay, first, I'm going to do the first number I see. A is equal to 3. Okay, B is equal to -5. Okay, now here's a problem. What is u equal to? Maybe I shouldn't have done B yet. Okay, so I think I'll go back and erase B. Okay, because, and maybe I should have just started with the variable anyway. Let u equal to x. Then du is equal to 2 dx. Okay, and dx then would equal to du over 2. Okay, now a would still be 3, no problem there. But the bu, if u was 2x, then bu is equal to 2bx. So your 5, the -5 here, has to be what your -5 is here is your 2b. This is an awkward way to do it, I think. So 2b, let's write it this way. 2b is equal to minus 5. So b is equal to minus 5 halves. I don't know if this was a reasonable way to say it, but I think it was all right. Okay, so b is minus 5 halves. All right, so let's plug in and see what this one is then. Our dx is our du over 2, so this is going to be a 1/2 out front. Okay. And then this thing here, now here, here is a 2 from here. Okay. Now, this thing here is that there. So you don't have to worry about going back and using the 5 halves and the 3's and stuff. Just write that radical just like it is. The square root of 3 minus 5x. That is your a plus bu. Okay. So plus, now this time we use a as a, that's the 3. Okay. And then we've got another integral here. I'm not sure we've got room for it. Yuck. So I think I'll write it down here. Okay. Plus 3 times the integral of 1 over, now the u is 2x times the radical. This is the same radical as this, so it's the 3 minus 5x. And then we have dx. No, yeah, because we took the 1/2 on the outside here. And that's still, I think I'm right on that. Okay. Now, this is where we have to go back to, but let's clean it up a little first. Okay. This part, the 2's will go out, and that just gives you the square root of 3 minus 5x. Okay, plus. Now, let's pull the 2 out of here. No, okay. The 2 is in front of all this, so that's going to be 3/4. Okay, pulling this 2 out, combining it with that 2, and that gives you plus 3 over 4. And then your integral is 1 over x, because we pulled out the 2, times the square root of 3 minus 5x dx. Now, I'm running out of time. I guess I don't have an opening in parentheses, so I don't need to close it or bracket there. Okay. Now, how are we doing on time? Oh, it's 11:40. Okay. Let's see how we did so far and where we're going to halt this thing. Sorry about this. We ran smack out of time here, and I had hoped we would finish this section. Sorry about that. All right. So we had the 1/2, that thing. So we got the square root of 3 minus 5x plus, and they said 3/2. I said, oh, no. Oh, but they still have it in the parentheses. No, they don't. So except for this, what I was starting to put, this is the 3/2. Okay, we're down to that stage. Okay, so that's where we'll pick up next time. We'll pick up from this stage to that stage, and that's where we'll go then. Let me get my eraser and erase there. All right, so we'll begin in example 5, finish example 5. We almost finished 8.7 but didn't. Here's your homework exercises. Number 3 is at Calc Chat and Calc View. 5 is just at Calc Chat. 7 and 9 are at Calc Chat. 11's at Calc Chat. 13's at Calc Chat. 15 or 17 are both at Calc Chat. 15's at Calc View. Don't want to get too far here. I think you can do any of the odds 19 to 39. They are all at Calc Chat. And I think you can do 41 or 43. They're both at Calc Chat. I hesitate to do too much more into 45 and 47 because I think those are their sines and cosine ones. So we'll stop it at 43 and we'll pick up the rest of those next time. It may be that ones like 29 may be difficult too. If so, pause that one and we'll do it. Hold that for next time. All right, any questions? Sorry, today was not a very good day. There's just too many things going on. Computer screwing up at the beginning, and then plumbing and other things here at the house, which is so distracting. Any questions?
The essay is due by this week or tomorrow.
Okay, glad you said that. That was one of the things I meant to say at the very beginning. Yes, it's due by Wednesday. Okay, Wednesday's the last day of class, so that's when it's due. I need it by, I think I put it out there on the Blackboard as being a thing to be in by 11:59 Wednesday evening. Okay, so you have all day Wednesday. If it's the email or the message or the whatever that indicates the time comes in after Wednesday, then you start losing points. So yes, if you can get the research paper into me by Wednesday, anytime on Wednesday, preferably before class, but anytime on Wednesday. After that, you start losing points, so don't go there. Okay. If you get it to me today with November date on it, you still get your extra bonus point. If you get it to me on Wednesday, no extra bonus points. If you get it to me tomorrow, no extra bonus point. Tomorrow or Wednesday, you get your score. After Wednesday, Thursday on, you start losing points. Yeah.
Is this the essay that was due in the beginning?
Yeah, I think you already submitted yours, didn't you?
Yes.
I thought so. Yeah, you got your bonus points already. It may not be out there on Blackboard yet. I'm so far behind on grading and putting things on Blackboard, it's pathetic. I'll blame a lot of that on my the leukemia, which caused the anemia, all these emia words. But another part of the picture there was just this stupid stuff they make us do with Blackboard now, having to put all that information in every week. That eats up hours of my time that I would have been grading papers. I'm having to do that on Blackboard every week before class. And I don't know if you notice this, you probably don't, but under all the weeks, there's weekly activities and the stuff that I just say, see week 1, see week 1. Well, I put the PowerPoints out there, but it's just, it takes me hours, literally. Yeah, last evening, in the afternoon before supper and then after supper, that's all I was working on, was getting the Blackboard ready for this week. And I could have been grading papers then, but they want us to do that other mess. And as far as I know, the dean and an associate dean are on the roll, so they can tell if we're keeping up with that. So sorry about that. And folks, I don't know if you realize this. This is my last full week of teaching. because next week is final exams week. My mini term 2 class, we have class one day next week on Tuesday, but all my classes meet this week. Next week I have one class plus lots of finals and stuff like that to grade. And then next January, I will only be doing administrative stuff for the month of January, and February 1st, I'm retired. So this is the first day of my last week of full-time teaching, so you just had it. It was not a very pretty sight, but anyway, you got it. Any other questions?
You just said you wanted one question for each homework.
Okay, yeah, that's what it is. If I were you, I don't want to do it. If you already got them and want to send them to me, that's fine. But if you're behind on your research paper or any of your tests, get those done first, because those count points. Your homework assignments, that's only if you're going to be a borderline case that may bump you over the top. Okay, so this is a little late to worry too much about the homework, but if you want one for this week, just give me one homework exercise for this week. That's all for this week. If you're trying to make up old ones, get your other stuff done first. Be sure you get your research paper in, your test completed, get those in, and then you can start worrying about getting me any past homework. I'll give you credit for them for sure, but yeah, just one per week is all I need. Yeah, to answer your question. But on the other hand, prioritizing, get your research paper done, get your other tests done, then worry about the homework. Okay? Does that make sense, or is that what you were asking?
Yes, sir.
Okay, good deal. All right. Any other questions? Great questions, by the way. All right. Yes.
I said no, sir.
All right, good deal. I'm going to stop sharing now because I'm running out of time. I've got another class starting really soon. And unless there's any last thoughts or parting shots, I'm going to end the meeting for us all. So take care, folks. We'll see you on Wednesday. Okay? Any last thoughts? Okay, people are leaving already. Take care. Bye-bye.